Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog, and we're going to talk about the extreme value theorem today and how it relates to derivatives. If you have a function, and first of all, if it's continuous on a closed interval from a to b, what's the difference between a closed interval and an open interval, you might ask? Well, the closed interval includes the endpoints, whereas an open interval would not include the endpoints. This is closed on both endpoints. So we're going to go with a closed interval here from a to b. If it's continuous and it's closed, your function has to have an absolute maximum and an absolute minimum on that interval. So if you take a look at this first graph here, this first function, number 1 right here, from -1 to 2, that function is, first of all, that's a closed interval. And second of all, it is continuous on that entire interval. This graph should have an absolute max and an absolute minimum on that graph. Well, where's the absolute maximum? The absolute maximum is right there. Okay? So I would say my absolute maximum, you would say the maximum is 2, or sorry, the maximum is 5, the maximum is located at 2. I usually tell my kids just to write the coordinate. At 2, the absolute maximum is 5. We have an absolute minimum right there. The absolute minimum value is 1, and it's located at 0, so the absolute minimum is 0, 1. Now you notice I was guaranteed an absolute max and an absolute min on that graph. The next graph, graph number 2 here, first of all, this is not a closed interval. It is closed at -1, but it is not closed at x equals 2. This is an open interval. So the extreme value theorem here doesn't apply. Now, on that interval from -1 to 2, it is continuous. Okay? But does this graph have an absolute maximum? The answer to that is no. This graph does not have an absolute maximum. Now, here's the thing. Maybe it does, maybe it doesn't. The extreme value theorem only says if it is continuous and it is closed, you are going to have a max and min. If it is not continuous or it is not closed, well, you may have an absolute max, you may not. You may have an absolute min, you may not. This one didn't have an absolute maximum, but it certainly has an absolute minimum. The absolute minimum value is 1, and it's located at x equals 0. Another graph here, graph number 3. This graph right here, we started at -1, we ended at 2. Well, everybody's going to say this is a closed interval. Yes, it's closed at the endpoints, but we have a discontinuity at 1, so this is not continuous on that closed interval. You can see the open circle at 0. So again, does this have an absolute max and min? It certainly has right there an absolute maximum. And again, that absolute maximum value is 5, and it's located at 2. So the absolute maximum is the coordinate 2, 5. Now, if you look down here, there's an open circle. This one has no absolute minimum. Now, here's the thing. If a graph is not continuous, that doesn't mean it doesn't have an absolute max and an absolute min. It just means it's not guaranteed. Now, what we're going to do on these next few problems is we're going to figure out what derivatives at these values are. At 3, 2, and -3, -2, we're going to decide what the value of the derivatives are. Okay, so first of all, let's find the derivative. When I'm working on my derivative here, f of x, first of all, I'm going to simplify this. This would be 9x squared over x cubed. And then it would be -27 over x cubed. Well, let's simplify f of x first. This first term would be 9 over x, which is 9x to the -1. And the second term would be -27x to the -3. So what I can do on those two terms is use the power rule. F prime of x would be negative 9x to the negative 2. The next term would be positive 81x to the negative 4. So this would be negative 9 over x squared, plus 81 over x to the 4th. And what I wanted you to do was figure out, well, what's the derivative value at 3? Well, this would be negative 9 over 3 squared, which is negative 1. And this would be 81 over 3 to the 4th, which is also 81. This would be negative 1 plus 1. The value here is 0. At the point 32 right there, the value of the derivative is 0, which makes sense because it looks to me like there's a horizontal tangent line there. The slope is 0. The derivative is 0. Let's look at the derivative at negative 3. I'd have negative 9 over negative 3 squared. Well, that comes out to be negative 1 again. I have 81 over negative 3 to the 4th. Well, that comes out to be positive 1 again. So this comes out to be 0. So the derivative at negative 3, comma negative 2 is also 0. It has a horizontal tangent line. So what are we noticing here? We are noticing I have right here, this is a relative minimum. And that relative minimum, the derivative is 0. The derivative at negative 3 was 0. Notice here I have a relative maximum. But the value of the derivative at 3 was 0. So maybe, just maybe, I can make a conjecture here that if I have a relative max or a relative min, maybe the derivative is supposed to be equal to 0. Well, let's keep going here and see what happens. Let's take a look at the value of the derivative for this function at the point 0, 0, which is right at the bottom of the graph right here. And it looks to me like that is not only a relative minimum, but that is also an absolute minimum. Now we're going to take the look at the derivative of this function, which is the absolute value of x. Now, I don't know if you guys knew this, but the absolute value of x can also be defined as the square root of x squared. So how am I going to find the derivative of radical x squared? Well, let's use our derivative rules. G prime of x, since this function is actually x squared to the 1/2, I would bring the 1/2 out front. X squared would now be raised to the negative 1/2. And the chain rule says the derivative of the inside would be 2x. If I do some simplifying here, the 1/2 and the 2 cancel, and I get x over the negative exponent would put the radical on the bottom, so I've got radical x squared on the bottom. But if you notice closely, this is x over the square root of x squared is the absolute value of x. So we have a new derivative formula. The derivative of the absolute value of x is actually x over the absolute value of x. Now what I want to do here is I want to figure out what the derivative values are at 0, or what the derivative value is at 0. This would be 0 over the absolute value of 0, which is undefined. So wait a minute. In the previous problem we said the value of a derivative at a relative max or a relative min, it could possibly be 0. So if I find where the derivative equals 0, I could find a max or a min. Well, this time the derivative is undefined. So maybe I'm going to find derivatives, I'm going to find relative maximums or relative minimums where the derivative is undefined. Maybe I got to look for both. Cosine, we had to throw some trig in here. I know you guys love trigonometry. Let's take the derivative of g of x here. The derivative of g of x would be negative sine of x. Now, what's the value of the derivative at pi, comma negative 1, which is right there? And you notice That's actually an absolute minimum. It's also a relative minimum. If you take g prime at pi, I am taking negative sine of pi, but sine of pi is 0. Again, we're figuring out the value of the derivative at that point, at that relative minimum or relative maximum is 0, or maybe it's undefined. So in order to find relative extrema, it looks to me like we got one of two things happening. Either I've got the derivative at that particular value equaling 0, or I've got the derivative at that value being undefined. So maybe what I need to do to find relative maxes and mins, and maybe it will help me also find absolute maxes and mins, is start looking for where the derivative is equal to 0 or where the derivative is undefined. In another video, I will show you guys how to use this information to find maxes and mins. For now, I'm going to end this video. If you guys like the video, please like and subscribe. I'll be posting some more videos later on. Look for the video that talks about maxes and minimums.